dive in. All right, can we see the PowerPoint?
Yeah.
Yes.
Great. Let me make it big. Okay, so before we dive into today's actual PowerPoint, I'm going to do a little bit of review to kind of answer some of those questions we got at the end of last week's class. So kind of going back to the real basics of plotting and navigating. So hopefully we all remember from chart plotting that we can, I'm gonna move my little thing down. We can get a position by using different LOPs, a bearing to an aid to navigation or a range to an aid to navigation. So we're using that aid to navigation as a point that we can get a position off of. Now, when there's no more aids to navigation, we use celestial bodies, the sun, the moon, the planet, the stars, as that aid to navigation, and we're getting a bearing and a range from them. So we have to, let me go to the next slide here. So we're basically finding that geographic position. And how do we get the geographic position of a celestial body? Two things. Do you guys remember?
Time is
No.
one.
So it's going to be declination is kind of like latitude, right? Declination is how far that celestial body is above or below the equator. So declination is equivalent to latitude, if you want to think about it that way. And then your GHA is equivalent to longitude. So your GHA and your declination give you that geographic position of where that star is in the celestial sphere. So where that star is on the Earth. And then we can use the sextant to get an altitude of that body, whether it's the sun. And that creates this circle of equal altitude, which is kind of like a range. So if the sun is at 45 degrees, and I know its geographic position, then I am somewhere, infinite possibilities of that equal circle, equal altitude circle around that observation of the angle of the sun. So when we look at it on a globe, large scale, that circle can be massive. It can be huge. So let me click here. Oh, let me go back. Okay, so going back to simpler terms, if we don't have something to get a range and bearing from, we're going to use a celestial body. So we need that geographic position of the celestial body, and we can get a bearing and a range. But we will call it different things. We will call it an azimuth instead of a bearing, and we will call it an altitude instead of a range. So it's not in nautical miles of range. It's going to be an altitude, which is an angle. It's an angle above the horizon. So we could kind of shift those things that we know about coastal navigation into celestial navigation. It's, I don't want to say the same basic concepts, but it's those two things that we're creating. So if we could picture that cone above that celestial body, that's what we're measuring. So if we wanted to plot this, a range and a bearing, it is way too far away from us to plot on a chart, right? We'd need like 20 charts or something. It's way too far away to get an accurate position. So what we do is we create an assumed position, and then we create our bearing and our observed altitude from the assumed position. So we are creating a point that we can take a bearing and a range from. And we'll go into assumed position, I think, on week 4 of how we get it and why we get it. But it's that point that we are creating a range and vary from. So we're not going to create the range and vary from the actual geographic position of the celestial body because it's way too far away. So we create an assumed position. And the cool thing is you can create an assumed position that is really off from where you are. But doing the calculation, it will correct itself. That will give you a larger intercept, so a larger range to correct where you are from it. So the assumed position doesn't have to be like spot on accurate or anything. It's just a number that we are creating, and we always create it on the latitude line, so it's easy to plot, and then we can get a range and bearing from it. When we draw our range and bearing from it, we draw a straight line, and the LOP is really that circle of equal altitude, the circle of equal altitude, excuse me. But when we draw it on our chart, it's such a giant circle that it's a straight line on our chart. So it's a straight line that is perpendicular to our bearing, or that azimuth. So that ZN is that azimuth that we are finding. And if we draw a line perpendicular to it, that's going to be our LOP, or our circle of equal altitude. And I know it's a straight line, but when we draw it on a chart, the whole circle of equal altitude is just so huge that we draw it as a straight line. Does that make sense so far? A little bit better than last week?
Yes.
Okay. So this was, I tried to create it in a fancy way, but this was what I was going from, a very simplified version of it. You know, the sun, circle of equal altitude, and what we're measuring is altitude. That's how we get our position. We create an assumed position, calculate the intercept. Okay, so HC here is the altitude that's calculated for the assumed position. HO is the altitude or the height observed. So this is what we observe, and this is what we calculate with our assumed position so that we can create an LOP, which we draw as a perpendicular line to our azimuth. I don't know if that helps. This was me trying to make it simple again. Basically the same thing I've been saying, that computed altitude versus observed altitude. I think I covered that. Okay, so this is what it's gonna look like when we plot it. And I have it plotted on a universal plotting sheet, but we can plot it on the chart as well. I just find it as a beginner, there's lots of other things in the chart that we can get distracted and confused by. So we simplify it by plotting it on a universal plotting sheet. But when we do our plots in like 5 weeks, I think, whenever we do our plots, we're gonna plot it on the chart. So we created those assumed positions, and then we had a bearing, and our range isn't an arc. Like our range is an arc on our coastal plots. Our range is now a line that is perpendicular to the intercept line. So this is that bearing line. And instead of creating an arc for our range, it's a line. So again, our assumed, yeah? Was there a question? Okay, so our assumed position with the bearing line, and then the LOP, which is normally an arc. If we go back like all the way to this one, it's our bearing line and our range, LOP, but instead of that arc, we're doing it as a straight line because that arc is so massive going around the globe. Okay, so what do we need to plot this position? What do we need to plot here? We need assumed position, bearing, and intercept. Those are the three things that we need to plot for each LOP. An assumed position, the ZN, which is the direction of the line, and then the intercept is that distance of how far you're going on your azimuth line. So what we need to plot: assumed position, azimuth, and intercept. And how we find that is using a site reduction form. So in this form, we're going to go into it here, but the things that we need are our assumed latitude, assumed longitude, that's our assumed position, the intercept, INT, and then the azimuth, Z and ZN. Okay, so what is all in this site reduction form? The first part, I put a little yellow next to, is the navigator's information. The second part is the nautical almanac. That's what we're going into today. And then the third part is Pub 229. That's what we're going to go into week 4. So navigator's info. What's the date? What body are you observing? What's your DR Latin long? General zone time, general description, approximate GMT, and then what was the actual time? I have CT, and that means chronometer time, but what was the time when you saw the sun at that angle or saw the star at that angle? You want to mark down the time. And then we have, let's see, chronometer error and GMT time. So all this info, we don't need a book or anything. We should be able to get it from other navigation that we've been doing. The next part is the nautical almanac. So this green section of it is nautical almanac. This first part of the green is finding that geographic position of the star. So we're going to find the geographic position of the star, and then that's where our bearing and our range come from, but we're going to create an assumed position. But we need that geographic position of the star in order, or the sun, or whatever it is, in order to find that assumed position. So all of this is what we're going to focus on today. That's GHA, LHA, and declination. So our declination is the distance above the equator. Our GHA is the distance from Greenwich to the star, and that's measured west. Our LHA is from us to the star. So from us to the star is LHA. And then the second portion of the nautical almanac is our sextant corrections. So our altitude and different refraction on the horizon, we can take into account temperature, we can take into account all these different corrections to really fine tune that measurement that we took. And we find those in the nautical almanac, which we're going to go into deep dive into the sextant next week. So this week we're doing a geographic position of our celestial body. Next week, sextant corrections, and then the next week, Pub 229. And that is where we are creating that assumed position and calculating an altitude using the assumed position. So then we can get our intercept, which is kind of that distance that we're going to get from our assumed position so we could draw in our line. And we also calculate azimuth, or that bearing line. So ZN is our bearing. HC, HO intercept is that distance. So we use the Pub 229 to find our intercept and our azimuth. So again, the things we need to plot are assumed position, which happens in our nautical almanac area, and then our azimuth and our intercept, which happens in the Pub 229 area of the site reduction form. And I had showed you this one, but same thing. Okay, I'm going to stop the share. any big questions about that? Did that kind of clear things up a little bit? Okay. Okay, I feel good about that. So today we're diving into the Nautical Almanac, and that's what's helping us get the geographic position of the body. So we can then use it to create a line of position for ourselves. Okay. Let's dive into the Nautical Almanac. Does everyone have Nautical Almanac?
Not yet.
Okay. If you have it, follow along with me.
Is that the same thing as like all the charts in this book?
That's on what?
Is the stuff in the Nautical Almanac the same as all the charts in this book? All the, I got that celestial navigation in a nutshell.
Oh, no, the Nautical Almanac's going to be specific to 2020. So you have to get a new one every year.
Okay.
There is the PDF that you have also. You could download the PDF. It's just going to be a little trickier to go back and forth.
Yes, the PDF is also in the Google Classroom. So it is all available online. But as you'll see today, there's a lot of back and forth. And I guess I just like things, hard copies of things anyways. Okay. Share. Okay, week 2 Nautical Almanac. Here we go. We're gonna kind of go just page by page, so you could kind of just follow along with your book. The first page, or the inside cover, we have, I wonder if I can just go back and forth. Hold on a second. Let me. I want to share it. Share. Share. Okay. I know you can't see the whole thing, but here I can go, why can't I go back and forth? Oh, maybe I have to show my whole screen. Sorry, I'm still new to Zoom. Share my screen. Okay. Let's see. Okay. Can you guys see me go back and forth between the PowerPoint and what I'm looking at?
Yeah.
Okay. There we go. Took me a minute, but we're going to figure it out. Okay. So, the first page has altitude corrections. So these are those corrections that we are going to use to fine tune our sextant reading. And we use it for stars, sun, planets. The moon corrections are actually on the last page. So you can see where it says sun, stars, and planets. And then dip. Dip is a correction for adjusting your horizon. If you're on, a low sailboat or kayak, your horizon is going to be different than if you're on like a, airplane carrier or something like that. But we're going to go into all of those corrections next week in our sextant correction lecture. But so this is just getting to know where things are on the almanac. So we have A2, which is, I'm going to go back to this one. So we have A2, which is our altitude corrections for 10 to 90 degrees. So those are our high observations of the sun or the stars. A3 is for an altitude of 0 to 10. So those are if we observe the sun right as it's rising or right as it's setting, it's only 0 to 10 degrees above the horizon. So we have a little bit more corrections to apply if it's low, or a star or a planet. Our next page is our altitude corrections for the atmosphere. So we have for temperature, for pressure, and then our apparent altitudes. So let me go back. So those are corrections. The temperature and pressure can create a refraction and those type of things. That's what we can correct for. A lot of times we don't even measure that because it's such a minor correction, but it's there if we want it. Okay, we'll keep flipping the pages here. Page 4 has calendar of different religious calendar, public holidays, civil holidays, and this is all 2020. So phases of the moon, all current on whatever year it is. Days of the week and days of the year, all just calendars of your almanac. Solar eclipses, different pictures of those of where you're going to see the solar eclipse. So there's going to be a solar eclipse. Oh, it already happened. June 21st, but it is not where we are. It's Africa, Asia, and then it stops. There's going to be another solar eclipse on the 14th, but again, it's in the southern hemisphere. We are not going to see it. Meridian passage of different things. Meridian passage means when something is right above you. So, for example, the sun is all happening around noon. So the sun, meridian passage, when it rises, and then it starts to set. Right at that peak is meridian passage, and that happens about noon. And that's, high noon. That's when the sun is the highest it can go, and then it starts setting again. So this is a graph, if you will, of the meridian passages of the planets and the sun. And then we get into our daily pages, and that is the majority of this book. So let's go back.
Hey, Bree, quick question. What would you use the meridian passage of the planets for?
You could probably get a local apparent noon on that. Maybe not. I don't really know. I've never really used that table.
Yeah, I've never heard of it either.
But would that not be more for planning? In other words, if you were trying to anticipate perhaps sighting of like Venus, you could say, oh, it looks like it's going to be roughly at this height at that time?
Yes, and for me, I would find that easier to do a different way. I guess you could see it on the graph, like it will be, if it's earlier than meridian passage, it's, here's earlier, it's rising and then it's setting. So if you're in, what are we in? We're in July. That later on in the evening, Mars is going to be gone below the horizon because it rises, peaks out at 0500 and then starts setting. So Mars is going to be like a morning planet, probably not in your evening stars. I guess you could use it in that way. Does that make sense? Okay. Okay, so our increment pages, daily pages. There's 2 sides to each page, but each spread covers 3 days. So we have January 1st, 2nd, and 3rd on both of the pages. And then the hour increments are in universal time, which is GMT. So just think of that UT as GMT, or that universal time. And then it's by hour. So on top of the hour is all of these different measurements. So we have every day of the year and every hour of the day. We have a measurement on the daily pages. And then we're going to have to apply corrections if our observations don't happen exactly at the top of the hour. And we'll go into how we do those. But let's see. On the left side, we have Aries. And again, Aries is that reference point that we use to measure basically our stars. Our SHA plus our GHA will give us the GHA of the star. So that Aries we use as a reference point. Then we have Venus, Mars, Jupiter, and Saturn. Those are our 4 navigational planets that we can see. And then we have a list of our 57 navigational stars. Now, these stars are going to be the same for all 3 days. So even if you're observing something on January 1st and you are seeing, I don't know, Rigel, something like that, down here, it's going to be the same for all 3 days for your stars, that they're not changing that drastically. Up here at the top, we have, does anyone know what these little numbers are next to the planets?
Magnitude?
Magnitude. So the smaller the number, the brighter the object. So in this case, oops, I think you guys can still see. In this case, Venus is the brightest, and then Jupiter, and then Saturn, and then Mars. So does anyone know what the magnitude of the sun is? I don't know right now. But it just means how bright that star is. So it's telling you how bright the planet is at that particular time, and then you also have the GHA and declination. And so the GHA and declination gives us that geographic position of that planet. And from the geographic position, we can, get all this other information. So we're using that reference point. So it's basically like the latitude and longitude of each thing at each top of the hour. Again, stars have the SHA and declination.
So I've got a question.
Yes.
So, I mean, the sun's real easy. But if you're out at night and you're not really skilled at astronomy, are there tools or like apps on your phone where you can identify stars?
Yes, and I'm going to show you how to, I guess, my way of identifying the star and correctly shooting it. So we're basically going to be predicting that at sunset, the brightest stars are going to be these, and these ones. And I think it's going to be at a 45-degree angle, roughly bearing due north. So if I bring my sextant to due north at 45-degree angle, and I move it around a little, the brightest star that I see would be the one that I'm looking for.
Okay.
And you could take note of what constellation, and there are constellation ones. We're going to get to those maps in here as well. But there's apps on your phone. You can use that too.
The quick reference, Celestial Navigation to Davis and Smith actually has a star finder section in it between summer and winter
Okay.
for the different constellations.
That's Davis?
Yeah, the little quick sheet that is at the store at the OCC.
Oh, cool, cool. Okay. So now we're moving to the right side. The right side has the sun. So we have the geographic position. We have the GHA and declination of the sun for all 3 days at every hour. We have the GHA and the declination of the moon. And then on this side, we have civil twilight, nautical twilight, for the moon or for the sun and the moon. So we have sunrise, moonrise, sunset, and moonset for all of your different latitudes. And then we will get into the corrections of how you can correct those ones. Down here, we have the equation of time. So technically how many hours are in this day. And then we have the meridian passage. We're going to be finding that meridian passage a lot. And that means that noon, that whenever the sun is passing right above our longitude and then setting again, is meridian passage. So we're going to be using that one a lot. Okay, has everyone seen the daily pages?
A quick question.
Yes.
Just the difference between nautical and civil on the twilight section.
Yes. I'm going to save that question for my when we calculate sunset slides. That's on week 5 because I have graphics of it.
Okay.
So it's just it's basically the number of degrees. Can't tell you what they are off the top of my head. Where the sun is above, below, and deeper on the horizon. So as the sun is rising, you know, I'm just gonna make it up, like if it's 20 degrees below the horizon, that's your civil. If it's 10 degrees below the horizon, that's your nautical. And then right at the horizon, that's your sunrise. Same with sunset. It's just in referencing to where it is above the horizon in degrees.
Mm-hmm. Okay.
Okay. Oh, I'm going the wrong one. Oops. Okay. Then if we pass all of the daily pages, so past December 31st, we get to the explanation page. Principle and arrangement. So this is, if you don't have a class like this is supposed to be explaining to you how to use the Nautical Almanac and what each of these things mean. So the Nautical Almanac itself is a great textbook, a great reference tool to learn different things. I like to highlight this one. I'll usually circle it or put something, a post-it in the book or something, to highlight the GHA. If you add east, subtract west longitude, gives you your LHA. And that's one of the main things on our site reduction form that we're going to be doing today. So if you can't remember if you're adding west or subtracting west or adding whatever one it is, it's right there in the book. But hopefully we all have either the site reduction form quick reference, or you have printed out one from online somewhere that you don't have to memorize it. But in case you don't, it's there in the book. What other things are good in explanation? Oops. They just show you examples of different problems. I think, like, even for me, who I know what they're doing, it's just a different way of doing it for me, so I find it too confusing to look at, but you're welcome to check it out. It's a great reference tool. Okay, 262, we have our world time zones. So that is different countries around the world, what time zones they are in. We're gonna learn tonight, our quick reference is to just divide our longitude by 15, and the nearest whole number of whatever that is gives us our zone description. But if we know we're off the coast of one of these places, they are normally keeping these zone descriptions. Okay, page 266 goes to our star chart. So we have the star chart for the northern stars and the southern stars. So this is a great tool to look at when you figure out which stars you want to shoot at that particular time in your particular location. Then you could use this to help you identify which constellation you're looking for. I've never been great at constellations, and typically if you're making like a crossing from Newport to Hawaii and you're shooting things at sunrise and then shooting things at sunset, you're going to be using the same constellations over and over again, so you'll get to know them and you'll get to know what you're looking for. I guess when I was first doing celestial practically, I was in the southern hemisphere and I got to know a lot of those constellations, which doesn't help me now because we're in the northern hemisphere. But anyways, the next page, 268, is our stars. And these are our general SHA for our stars for each month of the year. So we have our SHA and declination for each month. And then these are our stars, magnitudes. The next section, 268, gives us our index of the rest of the stars. Oh, I was already there. The 173 minor stars. So those ones, if we can help it, we want to pick one of the major stars. But if we don't know what we shot and maybe we shot one of these minor stars, this is where we get their information, their SHA and declination. So it is still in the book, but it's more general to the month. Also, there is a yellow bookmark. Has anyone ripped out their yellow bookmark? A quick reference to the selected stars is on your bookmark, as well as your altitude corrections. So this is like a perforated, easy to tear out of the book. So then you can just put it in your, what are we at, July 15th. And then the next day, or the next time you change your 3 pages, you just put it in there, so you don't have to be flipping back and forth all the time. The little yellow thing's your bookmark. Anyways, okay. Page 274 goes into our Polaris tables. So Polaris, our North Star, we can get a lot of information from our North Star. The first one is a very, just like our quick calculation for high noon, we can get latitude by noon very easily without doing that big long site reduction form. We can get an LOP with like 2 or 3 little steps. Same thing for Polaris. We can get latitude by Polaris by a couple steps, and we can get a quick LOP line. So that's great. then we could also do an azimuth by Polaris. So an azimuth checks your compass error. So if you had a compass on board and you got a bearing of the sun or Polaris or the moon or whatever, you can check what it should be bearing true according to the almanac and what your compass is reading what it's bearing, and then you can get that compass error. We're not going to go into all of the ways to get compass error in this class, but that is a huge part of Celestial. I would say the most, in my world, it's the most commonly used. We don't use Celestial for plotting positions, but we use Celestial daily for compass error. But compasses aren't as prevalent in the recreational boat world, so we're going with position, not there. Maybe we'll do another class on that sometime. Okay, going to 277, we have our miscellaneous tables. Okay, my pages are off. $277 for me is the site reduction procedures.
Like that's 278 in the blue book.
278, 279.
There we go. No, you're right.
So the new almanacs have the site, they're called cosine site reduction tables. So you have to do some formulas, some sine, cosine, inverse, all this math things to use these tables. And I'm pretty sure, I'm not 100% sure, that if you use it that way, then you don't need Pub 229. But I guess maybe it's the old school way now. The way that I learned, and I'm going to show you guys, is using Pub 229, where all the highest math you do is divide at one point. But it's mostly adding and subtracting, and we do one division thing. But they have this site reduction table in the almanac now. So, and here, 319, they have the cosine site reduction form. So again, that's, this is my site reduction form, but they have an example of one in the book too. So if you want to play around with that, feel free. But that's, yeah, the cosine site reduction form, to use the cosine site reduction tables. Okay, back to here. The conversion of arc to time table. We're going to be using that one a lot for our sunrise and sunset times. And then we have our increments table, and that's our corrections for when things don't happen at the top of the hour, like they are on the daily pages. So we go to these increments and corrections. I like to call them minutes and seconds pages, but they're increments and correction pages. So for each minute, so there's, excuse me, let me bring it up here. So each page has 2 minutes. So here's a 2 and a 3. So if you're looking, if you're observed your time in the 3 minute, you're looking on this side. If you observed your time in the 2 minute, you're observing this side. So with all of these, you have 2 minutes per page. And then if you observe something at 5, 18, 21, so that's 5 hours, 18 minutes, 21 seconds. We get the 5 o'clock from our daily page. So 0500, 18 minutes, and then 20 seconds or whatever I said. These little S here is the seconds. So all of these are the seconds. And then we apply the correction for sun and planet, or Aries, or the moon. And then, so we want to look at, one portion of the minute at a time. And then we also look at it separate too, using lots of papers here, that this is the correction for, basically for GHA, right? Our GHA was on top of the hour, so now we're applying our increments to figure out what GHA is at the exact location. Then we have the little v or little d and a correction next to it. So I'm going to show you where you get that little v and little d. These are going to be for declination, our corrections for declination. So you go in with our little v or little d, and then you get the correction. A very common mistake is to go in and say, I had 24 seconds. This is my correction to GHA, and this is my correction to declination. But I want to emphasize that declination is its own thing. You go in with what you saw in the daily pages, and then you get your correction. And we're going to do some examples of this, so don't get too overwhelmed yet. Okay, back to this page. Okay, so after minutes and seconds, we get our altitude correction. So yeah, I have XXXII. This is tables for interpolating sunrise, moonrise, sunset, moonset, etc. All of the rising or setting phenomena. So we're going to go into how to use this table when we do sunrise and sunset week 5. But this is where the table is for it. Again, we have another quick reference for the stars. And okay, I didn't put in, we'll do it here. The moon corrections. On the almost very last page, we have corrections. Oops. Ooh. We have corrections for the moon. So, like I said, when we were looking at our daily pages, we had our V and D and HP. We're going to be using our moon corrections for that guy, and we will do some moon examples as well. And then we have our ads, and that is our familiarization. Okay. Let me see this real quick. Okay, we'll dive into this one. So our formula, and this is part of the site reduction table that we're going to use, is GHA plus the minutes and seconds. That's what we used on our increments and corrections pages. Gives us the total GHA for the celestial body. And we are always, always, always going to be adding that minutes and seconds. And that's because the sun is getting, traveling westward. It's always increasing. So if we have something at the top of the hour, but we got it at, 5:30, it's going to be bigger because it's always increasing, increasing, increasing. It's traveling to the west, further away from that Greenwich line. So we're always adding our minutes and seconds. then we get the GHA for the celestial body at the specific time that we are concerned with. Then we apply our longitude, and we're going to add east or subtract west to get our LHA. So that is our local hour angle. So we got to remember, add east minus west for your longitude, and then you get your local hour angle. And in order to go into Pub 229, we need the local hour angle. So that's why it's so important. And meridian angle, forget about that. I think I'm complicating too many things with meridian angle. So it is on the homework, but I'm going to take it off the homework for the next one I teach. So don't worry about that one. So that is we're thinking about the geographic position of our celestial body. That GHA gives us kind of the longitude of where it is on the Earth. Our declination gives us kind of that latitude of where it is on the Earth. So our declination, we get the declination for the top of the hour, and then we use our D with our little d to get what our declination is of the celestial body. So let me show you that real quick. Okay, so get zoomed in here. Might need a second to focus. Come on. There we go. Okay, so we have our, here we go. Can we see this? We have
Hey, Bree, what page are you on, just so I can look at it in the book?
I'm on page 51.
Thank you.
I just flipped to a random page. It has no prevalent. I just flipped to a page, but I'm on page 51. Okay, so this is the GHA, and this is the declination. And I'm looking in the sun column. So the S tells us the declination is south. It's south of the equator. And then the 6 tells us it's 6 degrees. And then 43.6 tells us the minutes. That 6 is there, but then it doesn't repeat itself. And then it repeats itself on the next 5 hours or 6 hours. So even though it's not there, I know that if I was at 2100 here, it would be south 6 degrees, 46.5. So when I am writing down what my information is for the top of the hour, I want to make note as if in this hour, if I got my observation here at 1820 or something, that from 1800 to 1900 is declination increasing or decreasing. In this case, it's decreasing. So I'm going to be having to subtract my correction. So it's getting closer and closer to the equator. So on GHA, we always add our correction. On declination, we add or subtract depending on what happened in that hour. So from 1800 to 1900, we were decreasing. So the number's getting smaller and smaller. So I'm going to be subtracting. And then if I go down to the bottom, I have a little d with a number, 0.1. And that's what I'm going to write in. So then when I go to my correction page, I had 1.0. My correction would be 0.1. If I go a little bit further, my correction for 1 would be 0.7. So this is helping us kind of interpolate between what's going on. let me bring back PowerPoint. So my note if declination is increasing or decreasing to the next hour. So are we going to add or subtract it? And in that, so D, I'm going to put in right here what that D was when I looked at it on the daily pages. So then when I go to my minutes and seconds page, I can get what the correction is. Okay, we are going to dive into an example, but first we're going to take a quick breather. How you guys doing?
Good.
Good so far?
Okay.
Okay, let's take a 5-minute break. Come back at 7:35.